Before we go ahead and create our texture compositor HDA node, I wanted to show a couple of practical examples how I have used this tool to create new texture sets from downloaded textures that I got from the couple of sites. I'm going to start with the Megascans texture that I downloaded. So I went to the Fab, and in Fab you can download texture sets, and I went to got couple of surface tileable textures. So this is not one of the that I downloaded, but I'm going to show what I did. I got something like a 5 texture sets. So these are all from the Megascans, and you can ignore this new folder. This is actually this is a folder with the new texture set that is already baked out. But basically, if you download any of these surface material from the fab that are Megascans, you would get something like this, where every texture type is actually material input. Material type is its own file, which is obviously not very optimal way to work. And what I want to do is actually create this texture back to the Unreal. So I wanted to use it in Unreal Engine. In Unreal Engine, if you import one of these materials, you would actually go ahead and get the ORM channel packed texture, which would be occlusion, roughness, and metallic would be already channel packed, and then you can use it for the already set up Quixel shader. So I wanted to recreate it with the Megascans that I actually downloaded. It's actually pretty simple. Every subfolder inside this material folder has same texture set inside it, which is good about these Quixel Megascan textures. They are very consistent with the type of data that they give for something like surface or whatever you download from them. And also the naming obviously is very important when we want to do this. Naming should be also consistent, and it is inside here. So the naming is actually very important because naming is actually what is used to create some of these drop-down menus where we can select the file that we want to source our channel information from. So, but before that, let's go through the top to the bottom. So first of all, we have to select the batch, the mode that we want to use. The batch mode is going to be giving a directory to this. We want to give this directory parameter a folder path. Inside here you can see I am giving actually the root folder of these 5 texture sets. So the batch mode will look for folders inside this folder that I provide inside here, and it's going to look for textures inside every one of these, like that. So it's not going to look for any subfolders inside these folders. So something like this that I have already baked out is actually going to be ignored. It's only going to look one folder deep inside here, and it's going to look for texture sets in here. And one thing that is important to know that there could be, obviously it's not probably best workflow, but there could be multiple texture sets inside one subfolder. If I had like a 3 grassy gravel folders, materials, they would be basically pasted inside here, duplicated. Basically, there could be multiple sets in them, and they would be picked up as a different texture set, and then there would be like a 2 or 3 subfolders inside here with the texture sets created there. So, but for now, since we are having a really nice information from Megascans, it's good to keep one material inside one subfolder. So yeah, and then I have to provide also the file extension that is going to be searched for. So I know that in Megascans, all of them are going to be JPEG files. There can be many different file extensions like EXR or the PNG files. So if you know that you have multiple extensions for the textures, make sure that you give it a space separated extension. So let's say I know that I have some EXR textures, just put it in EXR and they are going to be picked up. So you can see that if I go ahead and download and delete JPEG, you can see my menu is empty now, and I JPEG, you can see it's automatically picked up again. And this menu is actually powered by Python script that I'm going to go through and show how it is all set up. So right, and then I wanted to, so that's good. And also the output too, we have to give it the source or the custom path to where to cook out a new texture set. So by default, it's going to cook it out where the textures are located. You can see by the source I have inside here, this is the folder that's going to actually be cooked out. But if you give it a custom, we can give it any custom folders, and basically then all the new folders would be rendered out to that folder that we give it, to the custom folder. So yeah, but I'm going to leave it for source since we're going to go through it all anyways. So next is the top controls. So these controls are basically the basic top network. So these top 4 nodes are the same buttons that you can get on the top node, where you can cancel the cook output and generate work items. And then there's a couple of custom, so like something like a delete all output files, copy unmatched files. So this will be actually give us ability to copy any files that are not our texture sets that are matched inside here, be copied to the new subfolder with the new texture set. So this is good for something like geometry that many times comes with the textures. So you can imagine that we have our textures and then also the geometry file like FBX file, and as long as this extension would not be inside here, it actually would be picked up and copied in this new subfolder. So that one, and ensure unique directory name. So that's a little bit advanced. I'm going to talk a little bit later about that. Then we can also open output directory, which is a simple Python script that's going to open up the directory that these are going to be baked out to. So by default, if it's at source, it would be this material folder. But if it's at a custom, then it would open this custom folder that we have provided. So there's also cleanup, remove failed cooked directories. So that's also advanced topic that's going to go through once we're actually going to build up the functionality. But for now, we don't really need to know much about that. And the actual texture set, how it is set up, it's pretty simple. So I want to give our texture set a name. So what I did is I call this Unreal Megascan surface, because this is the, once you, let's say, because I'm going to use the Megascan surface shader with this texture set. So this is going to be set up for the Megascan surface shader. So I do not have to create my own shader for the tiling textures. And I know that Megascan surface shader uses occlusion, roughness, and metallic in RG and B channels. That's going to be put inside. I'm going to actually show it this bit later. And this name is important because it's actually going to be inside. It's going to be appended to the common name of the texture inside new, and it's going to be used as a name for the newly created folder. You can see that file and leaves the code 4K underscore Unreal MS underscore surface. You can see this is the name of the of a texture set. So this is where this name is going to come up. So then there's a couple of JPEG quality options and PNG pre-multiplication, which I'm going to talk a little bit later about, but that's for the most part we just want to leave it as unpre-multiplied. So in the end, how we actually set these texture sets, it's pretty simple. So as long as our naming scheme for the textures is follows something like this, where we have our texture name and the last. So important thing is to note that our texture sets our texture should be named as name underscore its type. So basically the last underscore of a texture name is going to be used, basically anything after the last underscore of our texture name is going to be used as a type. It's going to appear as a type, as a menu item inside here. You can see that inside here, fallen leaves underscore AO, you can see we have AO. And every one of these have picked up its name. It's important to have, and it is important to know that after and before underscore, for the texture set to be a texture be picked up as a texture set, it has to be basically the same beginning and the common name, which I'm using this inside HDA as a common name. So the before underscore, before the last underscore, it has to be the same to be picked up as a texture set, which makes sense. And the type can be a single name, but that's going to be different for the same texture set. And yeah, so it's pretty simple and pretty straightforward. And once we have picked them up, you can see we can basically write. So this multi-parameter block represents our new textures that are going to be generated. We have to give it a name, base color. So then we can choose we want to get the information from the file, which represents these textures, or a constant value. So we can write something like if we do not have metallic information or translucency information, we can write out the constant value of 0 to 1. But since obviously we have color, I want to write color. Then we have to say from base color which channel to pick up. If you want to write for our base color in a red channel, we want to pick up our red channel from the base color texture. And then basically repeat it for the G and B, and then select the G and B as a which channel to source from the file, like that. And then we have option to write to the alpha. So for the PNGs, that supports alpha, we can write to alpha, and we have to give it extension to save to. So I usually use always PNG, but whatever the extension and whatever the Houdini extension supports, you can write to that too. And for the advanced, we can change the resolution. So usually just leave it at the native. And then we can also complement the green channel. So this is only useful for the normals. If you know that you have like a DirectX normal, and you want to convert it to the OpenGL normal, you have to complement the green channel. So basically you have to take a green channel and you have to 1 minus the green channel value. That would basically invert that channel, and then you would get the OpenGL normal map if you need that. So we have our base color. Let's go to the normal. So normal, obviously, again, we went to file, take our normal, RGB, PNG, that's fine, write out. And now actual channel packing is going to be in my occlusion, roughness, and metallic. So I do have ambient occlusion map through the Megascans files. I have roughness, but I do not have a metallic. So this is where the constant value comes in handy. I know that something like this, where there's just leaves, there's no really metallic information, so we can write to the 0, it's not metallic, and that's all. And another thing that we can actually use the displacement inside the shader. It's by default, it's actually inside Unreal there in this Megascan surface shader, there's actually displacement option, but by default it's actually not hooked up. And let's say I wanted displacement, I wrote it inside alpha channel. So basically we have set up our texture set that we want to create. And if I go ahead and generate static work items, so I have already cooked it, so I'm not going to cook it because it's going to do it instantly. But if I generate it, before you cook, you can actually go ahead and preview what is actually going to be cooked out. If you see these dots, if you press on them, so you can see that expected output, you can see this long path, and then the new texture that's actually going to be created. You can see it also has a tag of the a type that's going to basically the name of it. That's going to be as a tag at the end of it. And there is a couple of how to handle some of the errors that might come up, but we're going to do it a little bit later. Oh, and actually, let me talk about one thing that I wanted to show is actually show only common types. This is a very nice feature to have to prevent any cooking errors before we actually cook out textures, because this is going to basically check for the so basically it's going to get all the texture sets. You can imagine that we have 5 texture sets. It's going to put them all inside. Basically it's going to take all the texture sets and it's going to check if every one of these texture sets has, let's say, ambient occlusion. If all of them have, this menu item is going to appear. But let's say I actually go ahead and delete ambient occlusion from one of my texture sets, and then I dirty all. You see it's actually I don't even think I needed to do that, but you see it's basically disappeared from here because not all texture sets have this ambient occlusion. Let's say, and if I deselect this, you can see AO is back on, but obviously I do not have AO inside here. So this is a very nice feature to have to check if all the texture sets have actually all the types of the data that is for all other texture sets. So yeah, so let me actually select this show only common types and undo the deletion of AO. So yeah, and once we have done cooked them out, they should come out something like this. Another one that I got was actually the plant boxes that you can see in my Unreal. In my Unreal project, you can see also these are they're all baked out with the HDA texture builder that we're going to make. So this is basically one-to-one conversion to the ORM texture set, which we did inside here, but we wrote out displacement. Inside here, I say I do not want displacement, so ORM, and that's it. This is it for the introduction of the workflow and what the tool is going to do, and see you in the next video.